Okay, so now we're going to talk about active and passive humoral immunity. And we're really referring to the different ways that the body can acquire antibodies in order to fight these pathogens. So, if we're talking about active humoral immunity, we are actually being exposed to the antigen itself, and we're going to produce our own antibodies against that antigen. And passive humoral immunity, we're not having exposure to the antigen, but instead we are going to receive ready-made antibodies from another source. So that's the big difference. If we're talking about active humoral immunity, we have two types. We have naturally acquired, where we were actually exposed to that antigen or that pathogen itself, and then we produce our plasma cells and eventually our antibodies. Or we can have artificially acquired, which is essentially the basis of a vaccine, where we're having exposure to the antigen of the pathogen, and then we're going to produce antibodies against it. These are small amounts. It's not an actual naturally acquired infection. And the whole point of the artificially acquired or a vaccine is that it's providing the first encounter with the antigen, so it's priming our immune response, so that if we do actually encounter the antigen naturally, we would have what would be mounting would be the secondary response. So it would be much faster and more robust, and hopefully not as long of a recovery. So passive humoral immunity, again, we have two different types. We either have naturally acquired or we have artificially acquired. So if we're talking about passive immunity that's occurring naturally, this one example of this is when the mother passes antibodies to her baby through the placenta or milk. Or we can have artificially, through which we're getting antibody injections like anti-serums or even monoclonal antibodies that are being used in treatments. But overall, the active immunity is going to help build a long-term defense, while passive immunity offers a temporary, fast-acting protection. Downside to passive humoral immunity, because we're just receiving those antibodies directly, we're not actually forming our own antibodies, and we're not actually producing any memory cells, so we don't really have any protection beyond what we received at that point. Here's a nice flow chart that you can go in to compare all of them. And now we'll start talking about antibodies themselves. So antibodies are also called immunoglobulins. So we have 5 different classes, so that you'll see in a little bit, we call them Igs. So the basic structure of an antibody, it's going to be made up of 4 polypeptide chains, 2 identical heavy chains, and 2 identical light chains. And these chains are going to be held together by disulfide bonds. Some important regions, or at least the ones that I'm going to hold you responsible for on the exam, are going to be our variable region and our constant region. So the variable region is going to be at the tips of the Y shape. So right here, that's a variable region. And this is a variable region. So the variable region is going to be where the antigen actually binds, and this is what's going to give the antibody antigen specificity. The other region is going to be our stem region down here of our Y, and this is what we refer to as the constant region. So it makes up the rest of the antibody. And the constant region is going to determine the antibody class. Like I mentioned, there's 5 different types, so we have 5 different types of constant regions, as well as its function. Usually the constant region does not vary among the antibodies as long as they are making up the same class. So here's just a little bit of our 5 different classes of antibodies. You should recognize what they are. There is an acronym for it, and it's just MAGE to represent the different antibody classes. You don't need to know everything, all these details on the slide, but what's really important, I'll mention to you now. So IgM, this is the first antibody that's made, and it's actually a pentamer, meaning it's 5 of those Y-shaped structures that are linked together. So each antibody, the Y-shaped structure, has 2 antigen binding sites. Our IgM has 5 of these, so it can actually bind up to 10 antigens. So it makes it a really powerful antibody because it's able to bind and neutralize up to 10 different antigens. It's also really good at activating complement, which we've talked about previously. IgG is going to be the most abundant that we have actually in our blood, and it's going to help provide long-term immunity. IgA is really just found in mucosal areas, so things like our respiratory tract and our gut. IgE is really involved just in allergic responses, and it's also going to help with defense against parasites. IgD, we really don't know a whole lot about it, so I don't really expect you to know a lot about it either. So when we're talking about antibody production, our plasma cells, they can switch. We don't have 5 different types of plasma cells like we do for the 5 classes. So in general, our plasma cells are going to pump out and produce these antibodies. And they can switch from making one type of antibody class to another.